Hello. Our first lab talks about the charge tapes, and our objective, or the object of this lab, is to find the charge on a single piece of tape by observing, the interaction between two charge tapes. We can now find the forces acting of the floating tape by using the Newton's second law and compute the charge of each one. Physics principle that we use in this experiment is that the charges of the same sign repel, otherwise attract, and the electric field formula, and Coulomb's law, and the momentum principle using the Newton's second law, and the Effinent principle. Our experiment starts with making a U-tape by charging it by induction, and when we brought our hand nearby the tape, it got attracted. That means it definitely charged. And to find the sign of the tape, uh, we rub a pin on the hair so that the pin got negative charge, and we get it close to the tape, and they got repelled. That means that both the pin and the tape have negative charge. That's how we find the sign of the tape. So after bringing another tape with the same charge nearby the old one, they got repelled. That means they have the same charge. And if neutral objects got nearby charged tape, they will attract because of the polarization of the neutral object, and the plus particle will get closer to the tip of the neutral object, which is closer to the tape of the charge tape. Our experiment is to float a tape over another one. So our focus would be on the second tape, or the floating tape, and this is the main part of the experiment. So if the tape isn't moving, or the floating tape isn't moving, that means the momentum is zero, and we can now apply the Newton's second law between the forces of the floating tape, which is the gravitational and the electric force. This is the free body diagram. This is the electric force upward and the gravitational force downward. And since the length of the floating tape is 20 centimeters and 1 meters of tape equal to 1 gram, then the mass of the floating tape is 0.2 gram. So we have assumed that both numbers of charges of the tape are equal to simplify our calculations, because they will be too big or too hard to get the Q, or the charge of the both tapes, and because both tapes have the same mass and length. So we started our model by the constants, the Coulomb's constant, electron, and the distance we found, which is 4 centimeters, and the mass we talked about, which is 0.002 kilograms, because of the SI nations. Our function definition of the electric field, and we have the two objects here, which is the tape 1, which is the middle one, and the tape 2, which is the floating tape that we gonna measure. Both have the same mass. And to find the charge of the floating tape, we only draw forces on the second, or the floating tape. So we found that gravitational force equal to the mass times the g, or the gravitational constant, in the negative y direction, which is the orange arrow. And we can know that both gravitational fields and electric field, or the force, gravitational force and the electric force, were equal to 0 because they're equal, but because of the Newton's second law, and they're equal in magnitude but opposite in sign. That's how we found the electric force, and this is the gravitational force. And finally, we can now find the charge of each tape by manipulating the electric force, or the Coulomb's law, to find the charge. And this is what we done to find the charge by magnitude of the electric force. And we displayed our arrows by the electric force arrow and the gravitational force, which is the orange, and the cyan is the electric force. And we try to find the number of electrons in the sticky surface of the tape by dividing the charge over the electron sign or the electron charge, find the number of electrons, and we found the numbers of atoms by this equation and the ratio between electrons and atoms. Finally, our result is to find the sign of charge tapes, which we found it's the negative, and prove that charges of the different sign attract, otherwise repel. And our main result to find the exact charge of the floating tape, and finally found the number of electrons and atoms and the ratio between them.